Hi, today we will study about engineering of immunity. So we want to study our immune system and lymphatics and the role of vaccines and antibodies in disease prevention. So first of all, what's the role of our immune system? So our immune system is like a soldier or military system in our body, which will monitor if there's any invasion of pathogens, such as bacteria or viruses or toxins coming in. And then if we find it, attack it. And then also after this, prepare for the next invasion by memorizing and prepare. So the cells which comprises of this immune system has to know who is our enemy or our own. So that our cells have to distinguish a self from non-self. Non-self we typically call a foreign. So there are common features among different cell types in our immune system, which is the cells of immune system should recognize a self. And also it has a function to surveillance and defense and clear those who debris or after we attack those invasions. And for that, our immune cells also have to have a very good communication system among and between our cells. So that's signaling is very important. That could be direct cell-to-cell contact signaling, or the cells even signal by themselves, so that it's called autocrine, so it can maybe proliferate when necessary. Also, the cells signal from one part to the other on nearby cells, and that's called the paracrine. So we have discussed about circulation extensively because the heart disease is one of the major causes of death. Now, let's look at the other rest part, which is lymphatics. And there are lymphatic capillaries. So remember that in our circulation of blood, there's arterial, and capillary, and venous, and vein. So with this presence of blood capillary, in fact, there's an intricate intermingle of lymphatic capillaries together. The difference between lymphatic versus blood circulation is a closed system, while lymphatic is more like one-way road. So lymphatic capillary, you see, it's not a closed circuit, but it's an open in one side. So that tip of the lymphatic vessels, if you look at closer, there's a lymphatic endothelial cells, and these part of lymphatic endothelial cell has a flap-like structure that's linked to collagen filament to anchored to connective tissue, so that it's more like passive opening at the tip, which sucks tissue fluid into this lymphatic vessels. So how does lymphatic vessels connect to our major blood circulation, which is depicted here? We already know that the blood circulation. So from pulmonary or system capillaries, we have tissue fluid drainage into lymphatic capillaries, which is like this structure. And it has a valve system because the major part of lymphatic vessels, it doesn't have like pressure inducing organ like heart. So it's more like passive. So like a vein, it has a valve system so that it prevents a backflow. And also you can notice that there is a lymph node from here and there, which is like in the drainage system, there exists our immune military system, which observes the local things happening, what is coming into our drainages. So that's what lymph node, and I will discuss more about this structure later. And eventually what happens is this lymphatic vessels ends up connected to our main vein system, so that it, in fact, It's mixed with our major blood circulation. So that's actually the liquid portion of lymphatic vessels connected to the blood, and the blood contains what's called blood plasma. So when you centrifuge the blood contains many cells and also the liquid portion, and that liquid portion is called plasma, and you centrifuge, then the RBCs get down, and on top of that, a very thin white blood cells come up. And with the platelet, the color looks, because of the scattering, that's why we call it white blood. And typically about the rest is called the plasma. And plasma is that liquid component of blood, while blood cells are suspended. So here's an example of from wartime photo that a soldier was injured from a trauma from a bomb shell. And he lost a lot of blood, so he needs a transfusion. So this shows the transfusion of blood plasma. This one usually keeps it in a frozen way, and that plasma is important for blood transfusion, so that's plasma. And the plasma contains very important, mostly water, but it contains proteins such as albumin and also glucose, and many electrolytes. And also plasma contains a very important clotting factors, which is important to protect ourselves from blood loss. But for experiment, sometimes we don't need it. So we can make plasma without clotting factors such as fibrinogen, and that we call serum. You remember from cell culture, we add this cell culture medium with a serum, which contains lots of growth factors and proteins, but that serum do not need clotting factors. So that's why serum, or we call BSA, bovine serum, like this.